In this lesson, we are going to review the order of operations, and our objectives are fairly straightforward. We want to be able to simplify an expression using the order of operations, and to demonstrate higher level understanding, we're also going to insert parentheses into the expression, which would change the order of operations so that it'll fit the value that we want to be true. And of course, we're going to write and evaluate expressions to represent area. Of course, before we can get into order of operations, there are some pre-existing skills you've got to have. Obviously, you already have to know how to add, subtract, multiply, divide, and you also need to know how to evaluate exponents. When you work with expressions, a lot of times they're not just a one step and you're done type of thing. A lot of times you have multiple pieces. You could have 2, 3, 4, 5 steps, all that need to be done in a particular order. You can add and subtract, multiply, divide, subtract followed by dividing, subtracting, multiplying followed by squaring. But when you have operations, there is an order in which they are supposed to be done. And that order is, of course, important. Subtracting first and dividing second is a very different thing from divide first, subtract second. For instance, on the left, if we subtract first, 24 subtract 6 would give us 18. Dividing second, 18 divided by 2 would give us 9. Well, if we do that in a different order, where we divide as a first step, 6 divided by 2 would be 3, and then subtracting second, 24 subtract 3 gives us 21, we wind up with completely different answers. And so we need a way of communicating with each other. We need to have a standard set of rules so that when you write something down, everybody would understand what is the first one, what is the second one, what is the third one. Because it would be confusing if people did things however they wanted, and because it would be confusing if people did things differently for the same writing, we have established a set of rules. One set of rules which everybody has to follow, and we call it the order of operations. You are probably already familiar with having seen them before and having worked with them a little bit. Most people tend to think of the order of operations, and a lot of teachers have students memorize PEMDAS. I will tell you, I absolutely hate PEMDAS with a passion, because I've seen so many students make mistakes with this, because it looks like it's parentheses, exponents, multiply, divide, add, subtract. That's how it looks, and that's wrong. It is not parentheses, exponents, multiply, then divide, then add, then subtract. There are not 6 steps to the order of operations. There are only 4. And it's very common for students to get mistakes that way. The part that many, many students forget, multiplication and division, is actually 1 step. Whenever you have a combination of adding and subtracting, or multiplying and dividing in the same problem, it's not always multiply first and always divide second. That's wrong. The rule is whichever one is farther left, that's first. Mixed multiplication and division is done from left to right. And we have the same problem with adding and subtracting. It looks like adding comes before subtracting, and that's wrong. Whenever you have mixed adding and subtracting, it's done from left to right, the same way that you would when you read a book. And I'm certain teachers tell their students when they give them PEMDAS, I'm sure they talk with the students about it, but it's such an easy thing when you look at that so many students forget it, that I absolutely hate this thing with a passion. I hate PEMDAS because so many kids use it wrong. And it screws them up then. Instead, it's better to simply remember PEMA. That way you've got 4 steps. Now, I also want to note, ultimately, we really don't care what you do to remember it. If remembering PEMDAS is good for you, okay. But use it correctly. you're going to use PEMDAS, do it the right way. If PEMDAS is causing you to make a mistake, then you need to either fix the mistake or get rid of PEMDAS. So, looking at the problem, knowing that we've got our 4 stages, are there any parentheses? No. Do you have any exponents? No. Do you have any multiplication or division? Yes. So that has to get done first. 18 divided by 2 gives us 9. And then to finish it off, 9 subtract 4 equals 5. We're done. Continue further. Parentheses, exponents, multiplication, division, and addition. Subtraction. Are there parentheses?
Yes.
Good. So we have to do those first. 6 subtract 2 would equal 3. Do we have any exponents?
Yes.
No. Do we have any multiplication or division? Yep. 12 times 3 equals 36. And we're done. Do we have parentheses? No. Do we have exponents? No. Do we have multiplication or division?
Yes.
Yes. So taking that multiplication, 14 times 3, and of course if you're not sure, there's no problem going off to the side. 4 times 2 would give us 12. 3 times 1 plus 1 gives us 4. So we've got 42. And then 42 subtract 19. Alright, well we can do more scratch work off to the side. 3, 3, 2, and so our subtraction gives us 23. Alright, now we have one that's a little bit more complex. But that doesn't change the order. Do we have any parentheses?
Yes.
No. Are there any exponents?
Yes.
No. Do we have multiplication or division?
Yes.
Yes. Do we have both? Absolutely. So which one gets done first? It's not multiplication before division. When you have mixed multiplying and dividing, it's like a book from left to right. Which one is farther left, the multiplication or the division? The dividing is. That should be done before the multiplication. 20 divided by 10 equals 2. Now we'll bring down all our other stuff. Do we still have multiplication division? Yes, so now we need to keep going with this. 21 multiplied by 5 equals 105. Do we still have multiplication and division? No, so that's gone. With this last piece of adding, 2 plus 105, 107. I want to emphasize, mixed multiplication and division is done from left to right. I would also like to note that there are times when you can get lucky. If you do the multiplication first, there are problems where you can get lucky and get the correct answer anyway. For this particular problem, if you did multiply first, you would have still wound up getting the same answer of 107. But that's because of luck, not because of skill. Consider here. Are there parentheses? Yes. So do the parentheses first. 2 plus 3, that's 5. Are there more parentheses?
No.
No. Exponents? Yes. So we need to evaluate the exponent 5 to the second power, or 5 squared. Don't say 10. 5 squared is not 10. It's very common that students will make the mistake and say 5 squared is 5 times 2, and those students are wrong. You have to remember, exponents are repeated multiplication. 1, 2. It is 5 times 5. That's not a piece that we expect you to have written out, but we absolutely expect you to remember that. You are expected to recognize that this 5 squared needs to be 25. And so then, do we have more exponents? Nope. Do we have multiplication or division? Nope. Do we have adding or subtracting? 25 minus 5 equals 20, and we are then done. Okay. Parentheses. No. Exponents. No. Multiplying or dividing? No. Adding or subtracting? Yeah, we've got them both. Which one do you do first? Which one is farther left? With mixed addition and subtraction, you need to do the one that's on the left first. For this problem, the subtraction is on the left. 19 minus 3 would equal 16. Finishing the problem by adding, 16 plus 4 gives us 20. Our correct answer is 20, but I'm sure that there are people out there that will make the mistake. This is a problem that if you did addition first, just assuming that adding has to be before subtracting, you wind up saying 12 subtract 7 is 5. And you get a completely wrong answer because you violated the rules. I mentioned that there are problems where you can get lucky and get the correct answer. This is not one of them. I will also let you know, getting lucky and having the correct answer is still a bad thing. It doesn't matter if you're getting lucky, because luck doesn't hold up all the time. If you do things wrong and just get lucky answers, that doesn't mean that you actually understood what you are supposed to. And you don't deserve full credit when you don't understand what you're supposed to do. When you're not doing things correctly, you don't deserve full credit. Consider here, 18 divided by 2 times 3. What should we do first? We clearly have mixed multiplication and division. Which one is first? The division should be, because it's on the left. This should be 9 times 3, giving us the correct answer of 27. If you made the error of doing the multiplication first, you'd wind up with the incorrect answer of 3, completely different than 27. Here is one that demonstrates a higher level of understanding. Right now, the stuff written here is wrong. And I'm going to rush through this fairly quickly. If we followed the order of operations, 7 times 2 would give us 14. Then 21 subtract 14 would give us 7. 7 plus 6 equals 13. The way it's written, all the stuff on the left actually is 13, and 13 is not the number 34 that this thing says. However, we can put parentheses in here somewhere. Where could you put parentheses that would change the order of operations? Instead of doing multiplication first, and subtraction second, and addition third, we need to change the order so that it'll wind up giving 34. How could we do that? How could we put in parentheses to change it from first, second, third into a different order? Okay, well, one thing people could guess, what if we did subtraction first? If we did subtraction first, multiplication second, and addition third, would that do it? Right now we don't know. We're taking a guess and we're checking to see if it works out. What is 21 minus 7? That's 14. 14 times 2 gives us 28. And 28 plus 6 is 34. So yeah, it worked out. Putting the parentheses around the subtraction actually do change the order of operations from multiplication first into subtraction first, and it changes the answer to the one we were looking for. Let's try this with another one. 21 subtract 7 times 2 plus 6. So the same stuff on the left, but instead of equaling 34, now we need it to equal 1. So what can we do to get that happening? Now let's just take a guess. And I'm going to take a guess and simply say, what if we do adding first? Okay, if we did adding first, then we'd have 21 minus 7 times 8, which would be 21 subtract 56, and 21 subtract 56 is definitely not 1, so that's not going to work. What else do you think? Well, maybe we could put in 2 pieces. What if we did it like this? 2 sets of parentheses. 21 subtract 7 would be 14. 2 plus 6 is 8, and 14 times 8, that's not going to work. That's way too big. Okay. When you put in parentheses, they don't have to be around just 2 pieces. What if we did it like that? Or what if we did it like this? We can put parentheses around entire blocks of several pieces. In which case, this would tell us 7 times 2 is 14. 14 plus 6, that's 21 subtract 20. And that checks out. 21 minus 20 actually does equal 1. So we've got it then. Our parentheses needed to be put in so that they fit this. Alright, so when we evaluate these pieces, the order of operations can be easily modeled with area. How would you get the area of this left rectangle? Area of a rectangle is length times width. So it's 3 times 4 plus the area of the right rectangle, length and width. That's 5 times 2. And so the piece that we've done here in the blue was this set of directions. Write an expression. We've done that. Now we need to do the second part and actually evaluate. 3 times 4 is 12. 5 times 2 is 10. 12 plus 10 equals 22. And we're done. Last problem. How does the order of operations play a role with word problems? Basically, how can you use this in your day-to-day life? Well, let's say you decide to go out to the hibachi buffet. At the hibachi buffet, kids who are 12 and under, they're charged $7. But all the adults are charged $14. So if we have 4 adults and 6 kids go out to eat, what's it going to cost you? Well, this is what we could recognize. 4 adults have to pay $14 each. 4 times 14. And you have to add in the price that the kids pay. Okay, so there are 6 kids who pay $7 each. We can build an expression, and now we have to evaluate it. 4 times 14 would equal 56. 6 times 7 is 42. And 56 plus 42, adding those together, we get 98. So, if you choose to go out to the hibachi buffet with 4 adults and 6 kids, a party of these 10 people are going to cost you 98 bucks to go out to eat. And that's it. Keep in mind, when you have the order of operations, if you want to use PEMDAS, you can. I'm not telling you like it can't possibly work. But if you use it, make sure you use it correctly. Whether you use PEMDAS or you use PEMA, however you choose to remember the order of operations, you do need to remember these steps. Mixed multiplication and division are done from left to right. Mixed adding and subtracting are done from left to right. You should also remember, exponents are repeated multiplication. You don't just multiply the 2 numbers. Those are by far the most common mistakes students will have when they work with the order of operations. They don't remember these rules, or they do exponents wrong. Make sure that you avoid those very common errors.